reaction is effected. This principle is only applied to a equilibrium reaction, not any other reactions. So you know that some of the reactions reach a equilibrium. Equilibrium, what is the equilibrium? Equilibrium is a state where each and every condition appears to be static, appears to be same, no matter what the time period no matter how much time period you leave the reaction or observe the reaction. You can observe the reaction for years or days, it will appear to be same. Everything would be appear to be same. If there are colors will appear to be same, density, concentrations, everything would appear to be same. Okay, although we know that an equilibrium reaction is a going on reaction. It's not a static reaction, it's a dynamic reaction, and continuously it is changing. Okay. Now we are going to study the changes in an equilibrium reaction. How can we change an equilibrium reaction? What factors can cause the change in equilibrium of a reaction? And we are also going to study what happens when that change is given to the equation, when that equilibrium is disturbed. Now we are very interested in knowing whether the reaction will move forward or backward. Okay, you know what is a forward direction? Forward direction means left to right, from reactant to product side. Backward is the opposite, from the product to the reactant side. Okay. So Daksh, are you here?
Hello, sir.
Okay, great. So Daksh, we are starting with Lee Chatelier principle, which is the last topic of this chapter. So Lee Chatelier is written in the definition. Can you read, Daksh, what is written? Lee Chatelier principle definition.
According to this principle, when an equilibrium reaction is distributed, then the reaction moves either forward or backward so as to nullify the change.
Okay, that was disturbed. Equilibrium reaction is disturbed. Then the reaction moves either forward or backward so as to nullify the change. So this Lee Chatelier principle says very simple thing. He says that, is Utkarsh also here with us? Utkarsh, is it you? Okay, Utkarsh. But why can't you speak? We are not able to hear you. All right. All right. Okay, we'll believe you. And we suppose you are not anybody else and you are Utkarsh. Although it's hard to check if I'm John. What is going on? All right. All right. Yes. So I was saying that Lee Chatelier says that whatever changes occur, the reaction moves in such a direction so as to nullify it. Okay. So this is basically Lee Chatelier. Now we will see in what ways can we disturb a equilibrium. Then you can write each and everything. But let me explain few. 5 of these things are there. We are going to discuss them in detail. So, in how many ways a reaction can be disturbed? So, we are going to see 5 different ways. The first is change in the concentration of reactant or product. So, if I change the reactant concentration or product concentration, the equilibrium point will change. Okay. Now, my question to you is, will the value of Kc change if I change the concentration of reactant or product? Anyone? Come on. Yes.
Yes, sir.
Okay, the value of Kc will change. Okay, any other answer? Come on, Nikhil, Charan, Daksh, your answers, please. Value of Kc will change if the concentration of reactant or product is changed. Come on, answer me.
Yes, sir.
Okay, the value of Kc will change. So two of them, Daksh and Niranjan, are saying that the value of Kc will change if the concentration of reactant and product is changed. Okay, Nikhil and Charan, you are left. Please answer.
Yes, sir, it'll change.
Okay, Nikhil.
Yes, sir.
Uh, that is very, very bad. You all are wrong. The
Sorry,
value
sir.
of Kc,
It will not change. It only change if the temperature is changed.
obviously, obviously, the value of Kc only changes when the temperature changes. We have studied this in the previous class as well. So it is bad that you couldn't remember, but please write it down somewhere. This is very important that the uh, value of Kc will only change when the temperature is changed. Okay, not when any other thing happens. Be it any other thing. Okay, it will not change. Now, second, change in volume, pressure at equilibrium. So if I'm going to change the volume of the container, or if I'm going to change the pressure of the container, the equilibrium position will change. We are going to see in what direction, forward or backward, and in under what circumstances. Third, change in temperature at equilibrium. So change in temperature at equilibrium, as I just mentioned, it changes the Kc itself. Okay. So if the Kc is changed, naturally the equilibrium is disturbed. Okay. But it is not necessarily it is not necessary that equilibrium constant Kc has to change in order to give a change to equilibrium. Okay. So there are two different things. Change of the Kc and change of the equilibrium position. Okay. Change of Kc happens only if the change is there in temperature. What about the change in equilibrium position? It can happen in all of these five conditions. Okay. So although nobody is going to ask you the difference, but there is a little difference. Change in the equilibrium position and change in the value of Kc. Value of Kc is only changed by the temperature, while the equilibrium position can be changed by all of the five written in front of you. Okay. Fourth. Fourth is addition of catalyst. Now, addition of catalyst also changes the uh, no, I'm sorry. Addition of catalyst does not change anything. Addition of catalyst does not change anything. It only changes one thing. It only changes one thing. It only changes the rate of reaction. It only changes the rate of reaction. What do I mean by that? There is a particular equilibrium position. The equilibrium position remains the same, but it reaches faster. The reaction comes to it faster. Now, what do I mean by that? I mean, if there is a reaction going on and I know the equilibrium will come in one day, it will take 24 hours to achieve equilibrium. But I don't have that much time and I need the equilibrium to come within 1 hour. So I have to put a catalyst. So the same equilibrium point is reached by adding the catalyst. Okay, we are going to discuss it in detail. We are just seeing in one eye view. Now, fifth is the addition of inert gas. Inert gas, you know, like argon, helium, krypton, xenon. The inert gases do not react with any of the things. So we are going to see that as well. If you add a inert gas, where the equilibrium will move. Okay. Now, please just copy this, introduce the topic, Lee Chatelier, write the definition, write 5 of these points, then we'll discuss them in detail.
Sudden.
Okay. Let me know when everybody is done. That's done.
So done.
Okay. Okay, let's move forward. Now you see, we are going into a little bit detail now. We are going to see each and every of that changes a little more in detail. Now the first one. First one is applying Lee chatelier when a reactant or product is added or removed. Okay. Now there are a few points. Let's read them in order to understand them. Nikhil, can you read the first point?
Yes, sir. When a reactant is added, equilibrium in the reaction moves to a direction which favors the consumption of the reactant, that is the forward direction.
Okay, wait. Now, please see, when a reactant is added, okay, reactant is added, that means a reactant has now become an excess. Okay, so according to the Lee Chatelier says that I will nullify the change in the reaction. So what is the change in the reaction? The change is that you have added more reactant and the concentration of the reactant has become more now. So in order to nullify it, you have to reduce the concentration of the reactant, isn't it? So in order to reduce the concentration of the reactant, what do you suggest? What should happen? A reaction should move forward. And when a reaction moves forward, you all know reactant is reduced, isn't it? C minus X. We write C minus X, isn't it? So what is C minus X for reactant? The concentration is reduced by amount X. So definitely the reactant will move in a forward direction. Please read the second point, Nikhil.
Yes, sir. When a reactant is removed, equilibrium in the reaction shifts in backward direction to make up for the shortfall in the reactants.
Yeah. When a reactant is removed. Now, in this case, a reactant is being removed. Again, the Lee Chatelier will say, I will nullify the change. Now, what is the change? The reactant has been, the concentration of the reactant has been decreased as compared to the products, isn't it? Now the products are a little bit more in excess as compared to the previous equilibrium point. So, in order to establish the equilibrium, what will happen? The reaction shifts in backward direction. Now, what is a backward direction? Backward direction means from the products to the reactant side. Okay, that is from right to left. So that's why the explanation seems self-explanatory. So let's move to the third and then fourth. Please read the third. They all are very similar.
When a product is added, reaction shifts to the backward direction. New equilibrium is
Established.
established.
Yeah. This is
Fourth
also
point.
referring to the, okay, just the third one here. It is also one and the same thing, only written in a different words. Now, what you have done is you have added the product. Now, what is the imbalance here? Product has become more as compared to the reactant. And Lee Chatelier will again say, in order to nullify the change. So, what will you do to nullify the change? You will take the reaction in a backward direction from product to the reactant so that the excess added product is consumed, isn't it? Daksh, are you here? Daksh, are you here? Daksh, can you hear me, child? Daksh, please let me know when you can hear me. Okay, let's move to the fourth point. Nikhil, please read the fourth point.
When a product is removed, reaction shifts to the forward direction, which favors formation of more products.
Yeah. So in fourth, what we are doing is we remove the product. And as soon as we remove the product, again an imbalance happens. What is the imbalance? Product becomes less in comparison to reactant at the previous equilibrium position. So what is to be done? The reaction should shift in a forward direction so that the reactant decreases a little bit and the product is produced. Okay, so these were four different ways in which Lee Chatelier tells you something when a reactant or a product is added or removed. Okay, so please write it down. I'm sure you must have understood, and then we'll see a few questions about them. Give the heading, give the first point, and then write sub 4 points, 4 sub points. Nikhil and Charan, I suppose you must have done these Lee Chatelier in FITGIP before?
Yes, sir.
Yes, sir.
Okay, great. Daksh, are you here?
Yes, sir. So I was having internet issues.
I could guess that. Okay, Daksh, see, we are writing down, we are discussing in detail the first disturbance, which is due to the reactant or the product issues. Okay, so these are 4 cases. These all are very, very same. You can copy these 4 and I'll explain it in nutshell again. Just copy these 4. Backward direction. That is from right to left to establish a new equilibrium. In the 4th point, the product will be removed. Now, when you have removed the product, the concentration of product has fallen, and in order to nullify, the chatelier will say the reaction will move in a forward direction. Why forward direction? Because in a forward direction, more number of products will be produced. To nullify the change, what is the change that you are trying to nullify? The product which you removed, the reaction is now trying to nullify it. Your removal of the product will be nullified by the reaction. How? By producing more of the product, by making the direction forward. These all 4 points are very, very simple. Daksh, you must have also studied this. Are you remembering studying this, Lee Chatelier?
So a little bit.
Okay. We'll understand it very perfectly when we do the questions now. We'll take some of them. Let me know if you are having any doubt.
So done.
Okay, great.
Done, sir.
Okay. Daksh, you are on which point?
The last two lines.
Okay, great. There can be many theoretical questions on this particular part of chemical equilibrium, that is Lee Chatelier. It is also an important part, also a easy part, not at all difficult. It is easy.
Well done.
Okay, great. Now let's see some questions. Okay, here is a question for you. Now in this example, I have given you the example of Haber's process, which is N2 plus 3H2 gives twice NH3, production of ammonia. And I am asking you in which direction equilibrium shifts if A, B, and C happens. So let's see what happens when A is done. That is H2 is added. What do you think will happen? Direction of equilibrium shift? Any answer?
Sir, it will move in the forward direction.
Okay, let's take options from all of you. Come on. Nikhil, Charan, Daksh, give your options. Give your answers.
The forward direction.
Okay. Nikhil and Charan. Come on. Nikhil and Charan, the question is very easy. Can you hear me? Nikhil and
Yes,
Charan.
sir.
Okay. Okay, please tell the answer. It's very easy. H2 is added. Come on. Have you forgot how to calculate this? Nikhil, can you hear the voice? Nikhil, not able to hear you, child. Charan, your answer, please.
Sir, H2 is added, then one.
Come on, you shouldn't take so much of time. Easy question.
Forward direction.
Yes, it is forward direction. Yes, it will be forward direction because see Lee Chatelier. What did Lee
The
Chatelier
first
say?
point.
Yes, first point. First point.
Sir. Yes, sir.
First point said that when the reactant is added, the reaction will shift in a forward direction. So as to nullify the change, how the change is being nullified? You know, when a reaction proceeds in a forward direction, the reactant's concentration is reduced and the products is increased. You added more reactant and hence it is only justified to reduce the concentration of the reactants because you added them unnecessarily. Okay, so that is how you nullify the change according to the Lee Chatelier. Yes, the answer is the forward direction. Okay, B part, NH3 is added.
The forward direction.
Okay, any other answer? Nikhil, Niranjan, Charan, your answers please. NH3 is added, ammonia is added. See the points you have written.
In backward direction.
Again, please repeat again.
The backward direction.
Okay, Niranjan is saying backward direction. Daksh is saying forward direction for B. Let's see Nikhil and Charan's answer. Come on, Nikhil and Charan, fast.
So
Easy
backward
question.
direction. Sorry, backward direction.
Okay, Daksh changes answer to backward. Nikhil and Charan, your answers please, fast.
Sir, backward only.
Okay, is Nikhil not able to speak? Is his voice not? I'm not able to hear his voice.
Sir, should I call him?
Yeah, you just okay. The meeting is about to end, so let's do one thing. We'll end this meeting, and then let's rejoin and do the C part. Okay, so then it will be all right. Please rejoin.